All right, so the talk is going to be equality in Scala. I originally wrote this talk and gave it, and then it was like 20 minutes in the rehearsal. And then I had to expand it to 40 minutes for the actual talk. So depending on the amount of interactions, I think it should be somewhere in between. So I want to kind of go back to the sort of origin of what happened to the Scala language and then go back to like 1998. This is when Java was still in like 1.1-ish. And there was this huge conference called Uppsala that was like object orientation was the whole like a hot thing. And like the smartest people was like all converging into this one place to figure out like, how can we actually make this programming language like actual mainstream? And Guy Steele was kind of like hired into some microsystems and gave this like great keynote speech called like growing a language. And he himself is like the author of, Scheme, but he was also brought in because he's really good at writing like language specs and things like that, right? And in the talk, he introduces this concept called the small language and large language. Small language is sort of like, it takes short term to learn. It's like, you can kind of fit it into your head. Whereas large language, you have like more vocabulary and has like a more richer things you can do once you acquire the language. So to kind of like demonstrate this concept, he actually gave the entire talk using like English words that only has like one syllable. And if he needed to use like a more than 2 syllables, he had to like redefine the word. So in there, he says, okay, primitive is a word that everyone sort of knows what it means, and you can take it for granted. And look, because primitive, the word primitive have multiple syllables, he had to define it like this. And this concept of like a small language and a large language kind of applies to programming language, basically. And that's sort of like a whole theme of the talk. And APL is sort of like, he used this as an example where it's really elegant language, like sort of like the, like within the people who know the languages, where it's sort of like before like R existed and all these things. Nowadays, we think of like a data, structuring language or data processing language to be the thing, but this kind of predates the whole concept. So in there's like mathematical symbols, and you can treat like these like a matrix, and you can do all sorts of different elegant things, but the users can only define like words, English words. So the symbols were kind of like built in, right? And whereas Lisp is kind of like the opposite spectrum, where it's sort of not the most elegant thing. Everyone thinks of like, this parentheses and kind of clunky looking, but the user can actually define what looks almost like a primitive, because essentially like what Lisp does is to create a system in which you can create languages almost within itself, right? And another way of sort of thinking about this, and this is what he mentions, is that like Cathedral versus Bazaar, it's like around it's 90s, so everyone's talking about Cathedral versus Bazaar. And the one point that people sort of like miss in this whole Cathedral versus Bazaar is it's not the largeness of things or the chaoticness of things, but like, how do you meet the user, basically? Because Cathedral design, basically you have this one big designer person, and it may take like 100 years to design this like one huge cathedral, but ultimately like the direction of the cathedral is set like at one point in time, right? And everyone can basically like take the, like load off of like, I'm gonna do this foundation work, I'm gonna create these windows, but ultimately that's like the design is sort of set at the beginning. Whereas Bazaar, there is really no plan, essentially. Like you have this spot, people can show up, people can start selling things. But because there is no one plan, as the demand changes, like this year, like I don't know, like selling certain coffee item is hot. This year, like a selling laptop is hot because of everyone is working from home. Like, so like things can kind of morph to meet the user as the whole thing grows. And to some degree, that's kind of like a similar concept that he's claiming that it apply to the survival of the language itself. And Lisp is a great example where, you know, like even though it's not the most elegant language, if you look back, we know like which one survived between APO and Lisp, right? It's now part of Emacs. Seth is probably like still writing Lisp today.
The answer was neither.
And, you know, like, so that's kind of like, so as a, instead of thinking about small language versus large language, his proposal is to, let's make a global language. That should be the next language's goal, as a, like essentially, right? And he says, what about Java? Now that Java is 1.1, how do we make this thing global? And he proposes 2 concrete points, which is generic types and operator overloading. And as a sort of like an example, he used like a complex number. And he says, yeah, you can try to add a complex number into Java, right? Or whatever numbers. But he says, instead of adding a complex number, we should try to create a system in which you can add complex number into Java. And another interesting thing about OOPSL 1998 is that there was a side workshop going on that people basically came up with like 3 different proposals on how to add generics into Java. And this particular one that sort of won the generic Java sort of thing, headed by Gilad Braca, and also Martin Ordersky is in there basically. And my hypothesis is that when this talk was given, he was likely in that room, right? Because day before or day after, there was this workshop going on talking about generic Java. So to kind of go into more details on the Java virtual machine, you know, the essentially internally is a stack. So if you have something like C equals A plus B, each of these things, like the iload 0 means that, so the stack thing is on the bottom, but like a local variable is on the top. So each time you say like, you know, like the 1, A and B, you pull down these variables from the top to the bottom, right? So there's 198. So it's like iload 0, iload 1, and there's like 10 and 98, like 198. And when you say I add, they pops off, the addition basically means to you pop off 2, and then the answer gets pushed back in. So that's kind of like how the stack machines work. And if you think about this, the whole primitive thing again, primitive types from the Java machine's point of view is the stuff that it can essentially understand natively. So that's the primitive types. Whereas the box primitives are the objects that you have to create it inside of a heap. And in order for you to, let's say, we didn't have the generics yet, right? So you kind of have to scroll back and think about like, how do you make like list, like a linked list of things? And back then we used this thing called vector. Vector doesn't understand int, so you have to wrap it up in Java-Lang integer, which is the box type. So now 2001, around this time, Java was still kind of like considered to be like slow. It's just not super usable. Like web is taking off and everyone's like using like Python and Ruby. And like Guy Steele is doing these like a workshop called like a lightweight language. And in there, he basically says, a lot of these languages that are used are now coming from the industry. Like what is happening in like, like academia is kind of having like a identity crisis. Like we need to kind of get back into this game. And he created this LL workshop. And in there, he kind of says like scheme is in there, right? So that's sort of in the backdrop of what's happening. And 2008, if you fast forward, Martin Ordersky basically, I think he's been working on it for a really long time, but I think around 2008-ish is when it becomes like a really people started using it. I think that's when the first like Scala Day takes place or something like that, and like a book starts coming out. And in there, he says, Scala is a scalable language. And it's named so because it's designed to grow to meet the user where they are as gradual evolution of the language itself, essentially, right? And if you look at programming in Scala, I found this after I was like writing the earlier slides, that in the book itself, he actually does mention growing a language. and the Cathedral thing, basically, right? And so in that view, Scala, like at the time when Scala came out, these are like two things that he touted. Like we have abstract types and we have operator overload. Exactly the two things that Guy Steele basically proposed. And on top of that, we have now a purely object orientation, meaning that you can kind of analyze language as everything is a thing, like everything is a slot or everything is an actor. And Scala is everything is an object and everything is message passing because he unified the plus operator as method. And it's purely object oriented because now like there is no primitive types within Scala.any. These two kind of like a multiverse is now converged and unified into this one thing. And as an example of the complex type, I can point at Spire, for example. We did create a system in which you don't need like additional thing. The userland can actually provide like number like things. So we have intuitive and like object-oriented number types like Python or Ruby, and we have extensibility, right? So thus far we have almost like a utopian view of the Scala thus far, but I think any utopia has sort of like a dark side. Something is going on underground, and that's equals. So what is equality, basically? Thus far, any questions? Because, okay, no questions, that's fine. So equality is kind of weird to think about because we kind of like take that for granted. So I'm not sure if this is like 100% mathematically correct, but I'm gonna try to attempt what equality is, right? Without saying equal, I guess. Equality is an example of equivalence relation, right? And that satisfies this thing called substitution property. What the substitution property means is that if A and B are considered to be equal, the usage of that A and B, like f of A and f of B, they will kind of come out the same way. And of course, there is like the side effects and all these different things. So you kind of have to think of f to be this like a pure-ish function. But if you're a functional programmer, you've heard of the like a referential transparency, right? So it's kind of like similar concept, I think, where equality basically means that these are sort of like become referentially transparent, that like they kind of like if they satisfy the same thing, you can kind of consider them to be equal. That's the substitution property. And the equivalence relation is like a little easier to, kind of like concretely define. So reflexive means that if you have A, any of those numbers or things, like the same thing is the same. So A equals A, except for not a number. Usually when you talk about this, not a number is like a weirdo because nothing equals to not a number, including to itself, I think. So except for not a number, A equals A. Symmetric, right? So you can flip them around, and transitive means that you can do like A equals C and B equals C. So
6 minutes.
So what is equivalent but not equal, I think is kind of like another way of thinking about this. And the humans are kind of like a visual animal. So you can kind of look at this, like if like a toy that's lying on the ground, you can kind of tell these are like a same-ish object. So we can see they're congruent, but they're not equal, right? Like if this was someone's GitHub activity or something, then these are absolutely not equal. But if there is your object, then you can kind of say, okay, they're kind of same-ish. So that's an example of equivalent but not equal. You can define the equivalence relationship of this. So the primitive types in Java, we have Boolean, chars, and all these different things, right? The interesting thing about Java is this thing called numeric promotion. So technically speaking, in Java, you're basically comparing two doubles. So when you have left-hand side and right-hand side, the if the left hand, either side is the double, you promote it to double. If it's either side is float, you promote it to float. So you kind of widen it and then you compare. So you're not really comparing integer and doubles. They're just like two doubles that are being compared in Java. So that's, yeah. So if you're comparing two primitive types of equality, you just kind of do like identity check. But because of the promotion, it's able to do 1 equals 1L in Java. The boxed one gets a little more complicated because in Java, you have this equals equals and the English equals thing, right? So the equals in double, like in Java, is an identity. So it's checking it's like a real object or not. So 128 is like a weird example where the value of will be equal. The value of actually will be false because Java actually, it leaks out. Yes, so there's a question. This talk is online, so I'm going to use the discussion clock to.
Hey, we can interrupt you with questions when you're not in the middle of a sentence if you want, Eugene.
Okay. All right. There you go. Yeah, so where was I? Integer, so two integer value of, these are basically false. But if you pick a number that's slower than 128, they actually come out true. And integer and long, they're incompatible types, so it actually errors out. So to sort of like do like a semantic equality, the Java provides this equals, right? And there's a whole hash code thing that happens to do, if something is equal, you have to have the same hash code, basically. And equality in Scala is that for value types, we use a numeric equality, but for reference types, we use equals. And why do we have to do this? Is that whole unification of the left and the right side, right? So because we have primitive types and the object types and under one uniform thing, it basically provides equal thing to mean sort of like a both. And if you have to get out of that, you can use this EQ to mean the identity equality. And that creates this like a weird thing called the cooperative equality. And it's basically emulating the numeric promotion of the box primitives. So here's an example basically where if you say Java-Lang integer of 28 and Java-Long of 28L, remember if you're using Java, this would error out, right? But in Scala, if you use equal operator, this returns true. And this is because if you upcast 128 into any, it automatically wraps. So there's like automatic boxing that's happening. So inside, like when you do 128 into the Java-Lang integer, this allows you to basically create a set of 128, 128L, and foo, and that will return basically 128 and foo because these things are called basically equal. Yeah, so in short, basically equal equals is different from the English word equals in Scala. And to work around this hash code thing, we also have this like a weird hash. And what hash does is that it is aware of the cooperative equality notion of what 1.0 means. So if you do 1.0, any hash, it returns 1, which is what integers hash code is, essentially. So this trips up even the Scala teams. And there was actually a bug in 2.13. I think there's this one, there's a number, 11551. This, I'm guessing this is the RC something of 213. It could be the actual 213 itself, where you put like 1L, 2L, 3L, 4L, 5L, and you add 1 into it. There is like extra 1, even though this is a set of any val. And Yoshida-san actually sent a fix for this. And that's literally like changing equals with a double equals. So he also said, like, since this is fairly, common mistake for anyone to hit, why don't we sort of like just catch this in the compiler time and warn the user? So that's a pull request I sent, 8120. So since 213.4, now if you write this, it will actually say that because of the cooperative equality, this, you shouldn't use equals and you should use double equals. All right, so the primitive types, like where is this even done, right? So this is basically done if you want to look into the compilers inside of the backend. So there's this thing called like a B code bodybuilder, which is kind of like macho sounding name. So the inside of the bodybuilder, all these like bytecode is generated. I'm not going to go into all the bytecode details, but essentially it's doing what you expect to sort of like Java to do. So left side and right side, it checks for the null. And the one thing it does is that there is this thing called like a boxes runtime. So that's the part like you kind of look into if you really are curious about this. So that's the part that does the promotion and all that stuff, is Scala runtime, boxes runtime. And because of the any, we are able to essentially kind of like compare like all of the values within Scala using this equals, right? And that's sometimes we call it like universal equality. It kind of sounds like cool. Like if you don't know, like, oh yeah, like it's kind of cool that we can now compare all these things. But from a type safety perspective, like it's basically unsound, right? Because the purpose of the type system is to be used as like a lightweight proof system that you're not passing weird stuff into your function. But because of this universal equality, the stuff that Java can catch, we're not catching. So yeah, so Java has a strongly type equals. And for what like benefit are we doing this? And I'm guessing we're doing this because of this numeric niceness, right?
Can I interrupt you with one question?
Yeah, of course. My clock is probably ran out, and like I'm just like waiting.
Are you
for some...
aware of what's happening in Scala 3 to put the two talks together around equality?
Yes.
Okay. Do you is that already included in your talk?
Yes.
Okay, never mind then.
Way to go, Josh.
Great question though. So before we go into 3, we have to talk about sort of like the functional way of trying to do this, right? So Scala Z around 2010-ish, like they implemented, like this is how equality should look like. You have 2 types, you have triple equals, boom, done, right?
I also believe it should always be triple equals.
Yes, just like JavaScript, it worked out for them.
It's even better with 4 equals or 5. That way you can sort of clarify that you really want it to be equal.
Exactly.
And on Halloween, you have to use 13 equal signs just to be safe.
Yeah.
Most people disable their CI on that day just to prevent sort of non-reproducible errors.
The kind of issue with this is kind of, I think, the Scala Z7 style, because the A doesn't have minus or plus on there, is that it ignores that we are an object-oriented language, basically. Not ignores it, but like in reality, like Scala 2 is object-oriented language, right? We have none, we got some, they have different types. These are not just constructors, we're not Haskell. So it gets into this weird trouble, like, so like we have this like a weirdness, like, yes, we don't want universal equality, but we also don't want like invariant equality either. So 2011, like there is like, if you Google this rethinking equality, this is like email Martin sent out. And he says, now that 2.9 is almost out the door, we have the luxury to think of what could come next. And he says that like the longer he looks at equality, the uglier it gets. So like he was certainly aware of the issues regarding equality, like, or universal equality especially. And he says, yeah, popularity of triple equals, right? But unfortunately in 2011, we couldn't really get into like a conclusive, here's what we should do idea. There was like all these waffling, oh, we can't break all these different things. So 2016 is when the multiversal equality is actually proposed. So what is multiversal equality? This is this strict mode that you can enable in Scala 3 with this language strict equality, or you can say import Scala language strict equality. It's so strict that if you say options 1 equals option 1, it actually doesn't work. It rejects it right now. You're supposed to provide a given proof. Hopefully it gets fixed. But it's a system basically kind of like you're able to create like a multiverses of equality so that you can say that within this ecosystem, these things are equal. So like, thankfully, there was an automatic derivation in Scala 3. So you can just like very easily say given, whatever that equals A1, A2 extends into the options of it. But this basically potentially can be like the next strictness into the equality thing. But here's like a catch, is like, this is sort of like a weird issue that I have with this, is that if you look into the EQL companion object, there is this thing called given equal number, right? Which means that it's still doing this like a closed numeric promotion thing amongst all the numbers. Why is it sort of like bad? Or I think it's sort of bad, is that cooperative equality is basically a closed world system. So there's this long-standing thing like, can Spire actually join the equality club? And no, not really, right? Because think about like complex is maybe, it's a good example, I guess. In complex numbers, you are able to like express a concept of 1.0. So if you say complex 1, 0, and 0, 0, it should be semantically equal to 1.0, right? But you can't. Why? Because it needs to be kind of like is it reflexive, right? So 1.0 is unaware of what like Eric is doing. So Eric is the author of Spire. And Eric can know about 1.0, but 1.0 can never know about Eric. And therefore, it's a club that only sort of like a built-in types can join. So in sort of like in the sense of the, like a growableness, it's not really great, basically. So I was thinking like, what happens to Valhalla too, right? In Valhalla, there's this concept called substitutability. Kind of sounds like I was hoping it's like going to solve this problem. So I asked Brian Goetz, like, what about numeric promotion? Like, are you going to do something about this? And he's like, yeah, probably not really. So likely the Valhalla is not going to change the idea of the numeric promotion. Maybe in the future, there is going to be a way for others to join. So my sort of like the proposal to Scala 3 to making it growable is to essentially like, we should remove the cooperative equality under the strict mode. And the niceness is that this talk basically becomes irrelevant if it's done, right? Because we don't have to worry about the English equals versus equals anymore. If the cooperative equality is gone, then they are basically the same thing. You can just say these are two different objects, then they're different.
So like, there's a lot of this is an interesting proposal because it's like it's in the same category as a lot of things that have been discussed, many times over the years. Like one random example of it being the collections library that I proposed for 213, right? And like my question for you, Eugene, is why do you hate Java developers? Like you're just making it harder for like people who are used to this kind of cooperative equality semantic to kind of, start using Scala, right? How do you help them along?
So I think one way we can help them, right? So why do you hate Java developers? An example, failure example is if I say 1.0 plus 0, would it now error out, right? It's sort of like a question I think you were saying, right? I don't think it should error out. The interesting thing is that I think there is a whole different concept that Scala 3 added that's able to promote like the constant looking things into another constant. I forgot the exact name for it, but basically like you treat the literal of the 0 as kind of like a flexible tree and you don't type it immediately because that's exactly what Java is doing, right? When Java says 1.0 equals 0, that 0 is not an integer. It's not typed yet. Like you just kind of promote it into, lift it sort of into double, right? So if we can have a fair system that can promote literal into like complex type using just like you just need a just, but you need the implicits or the givens to go from a string to the number, then we can just basically treat that. So I don't know if that answers
before someone writes a monoid type class that uses the 0 literal.
I just want to point out that C++ supports implicit constructors that do this, and no one considers this a mistake or a failure that I know of.
Yeah, implicit constructors are actually kind of nice. Like they're a lot more constrained than implicit conversions, and they generally solve this problem fairly well.
Yeah, and when you have a system that doesn't have garbage collection, it's incredibly safe to do this. For those of you who don't know, I'm being sarcastic. That's very highly sarcastic. Quick question for you though. So like to some extent, widening, not all widening, but some widening can be done, relatively efficiently in hardware. Or you have numbers that are represented equivalently, like in memory, right? So there's actually some complications here around like, can I look at a set of bytes and they're equal, right? Versus not. Mm-hmm. And can I take a set of bytes and just throw a bunch of zeros in front and it's the same as the other one that I want to throw in there as well? Or like, is it efficient for me to widen this thing? Like, can I do this in a limited subset of instructions versus say complex, right? Where complex, the representation of it is not necessarily the same as the representation of say 1.0, the floating point number, right? So the comparison is not necessarily efficient. So one of the things to think about when you write equal, right? Or when you write EQ, or when you write equal, or however many of them you put in a row to make it be what you want, is to think about how efficient that thing actually is, right? Because equal, I think most programmers think of as a relatively efficient operation, as a relatively quick operation. And one of the things Scala has done, like it or not, is because it calls dot equals, equal, it no longer has that association with it in Scala, right? However, we think of that when it comes to primitives. You still think of equal being fast. So if you're going to kind of put this on even playing fields, right? There's still a notion to some of us performance-minded folk of, I want to know which one guarantees that this can't get screwed up in my code, that I can't make a mistake myself that would lead to this not being like an efficient piece of bytecode, right?
Well, if I can step on Eugene here because his chess timer is out, so he's not allowed to speak anymore, ever. We already have a little bit of that, but without the static checking. in double equals right now, where like if you happen to be using double equals in a situation where no promotion is required at all, you will get a very fast bit of bytecode because the compiler won't insert any hijinks. It will actually just emit the, IEQ or whatever the instruction is, right? And even if you get a promotion situation, as long as it's a relatively straightforward promotion, that it can just delegate down into bytecode, that will also be like very, very fast. And worse comes to worse, you can always use EQ. So like EQ is there. And for those of us performance-minded folks, which is really just code for we use sunmisc unsafe and we use EQ on our type class instances, like that's there, and we can use that within the hot path to like make sure that we have full control over this semantic. What I think is more interesting is like there's a coincidental alignment here between the cases that can be efficiently handled in bytecode and the cases that don't require weird, and the cases that can be statically checked in a nice uniform way. So in theory, it feels like the multiversal equality could address that, Josh, as long as the compiler has a fairly deep awareness of it on primitives.
Yeah. So I think if we get rid of cooperative equality, right, I'm sort of saying like we're going to get simpler because we can get rid of all that checking feature that we do during the runtime, because that's what's happening already in the runtime. And then it becomes the simpler just equality check that essentially the Java machine itself has all these different instructions to be able to do. And the same goes for like the collections and stuff. We can just use the Java collection straight up without worrying about what do the numbers look like in Scala versus Java. So that's all for me. And any other questions?
Yeah, I have a question about the language strict equality flag in Scala 3. Do you recall why that got stuck behind a flag and sort of postponed for full consideration until later?
I don't know why this happened, but it sort of like goes back to earlier talk by Daniel that maybe there are cases where this would just be inconveniently strict for some people. Or it's just that like we thought of this as a concept, but it's not sort of seriously being tested yet. So maybe it's kind of buying us time a little bit to fully mature this feature into more serious usage. So like cross-compiling will be kind of difficult if equality doesn't even work, right? But I think this is actually a really great feature because I bet in your code, I found this in like compiler, literally it was like testing like equality between like, I don't know, like string and option of string or symbol and type or something. That thing should never be compared with equality. A lot of the code base, if it's large enough, is likely testing right now, and it will just always return false. And like compiler sometimes wouldn't even catch it if it's complex enough, basically. So yeah, so I don't know the exact answer, but the likely backward compatibility is one of the huge reasons, I think, and also maturity of this feature itself.
I wonder if another reason might be the whole question of equality in collections, because if I understand correctly, this multiversal equality proposal improves the situation when user code uses a double equals operator. But a lot of the equality comparisons in Scala are actually happening in the collections code, right? Every time you say every time you call the contains method on a set, it has to do an equality comparison. So I wonder, I don't know if this is if this is one of the actual reasons it was held back, but I can easily imagine that considering this whole equality question requires broadening the scope to the collections design, which is not free to be changed in 3.0 because the standard library can't change. Where I assume the redesign would take the form of an equality type class. that the collections code would use instead of just directly calling double equals.
Yeah, that's a great point, because I think like Scala Z went through a very similar thing where like they have triple equals, it's great, but it doesn't, no one respects that in the collection. So they would create like different version of the set or something like that, right? That will kind of like do the invariant triple equals inside of set or something. So yeah, if we want to propagate this out into the next phase, yeah, maybe we have to wait till Scala 3.t or whatever we call it, where we can actually break the, you know, the collection library and get rid of the training wheels of 213.
I think a related question is the importance of having hash code with equals. I would argue that hash code is as important as equals, and there's just the general question of should you provide these by default for all types. You know, there are languages that don't, and they suffer from weird things in libraries that those of us on the JVM kind of think are bonkers, but it's because they don't have universal hash code or universal equality. But my question with multiversal equality is, what does multiversal hash code mean? Like, those two concepts are generally highly correlated, right?
Mm-hmm.
And so if I'm going to provide this multiversal equality of when those are compatible, do I also need to do something similar around hash code comparisons and hash codes?
Yeah, I think that's a great point. So that basically points to my thing about like numbers too, right? Like you can't just later on join the club because precisely of the hash code restriction. So I think multiverse can only solve like breaking up the universe into tinier pieces and basically return false when it wasn't before, but I don't think it can return true when it wasn't false before. Right. So that's why it's a multiverse equality, not like a whole brand new system, I think. So if you're today returning true, then like changing that, I think will be trickier. Or you can't just like, so you can only go stricter, I think, because of that reason, I think.
I think you can relax it too if you're pathological, because you can define an equal that's like, I'm going to compare string and int. And, you know, now what does that mean? Well, you were allowed to do it. And, you know, you can pass that around and your collections have to deal with that. But what does that mean for things that are correlated like hash code? What does it mean for, you know, anything? You've just sort of done nonsense, but you've done half of nonsense, right?
Yeah, well, I guess you can do that at compile time, but at the value time, like it can't return suddenly true when it was false because your hash code needs to also match up too, right? Unless we do like a typed class for hash code as well, but there is no typed class for hash code, I guess. So Josh, are you suggesting we should have a typed class? I think that could be actually be an interesting proposal, I think. If it compiles away, I guess.
So it gets really interesting when it comes to collections because there are collections that rely on equality that also generally rely on hash code for efficiency. Not all of them, some of them rely on comparability. But if you can't provide both of those operations and you want to create your own separate universe than the built-in universe of the language, right? That's when things get super interesting and you need to kind of lift it as a concept that can get encoded. It's kind of like the earlier collection library where you had this can build from thing that would change how four comprehensions worked and change the universe that you operate within, right? I see it getting a bit ugly, frankly. And the question is, you know, is the fix worth the pain? Is it enough of a problem that it merits that solution? Like we take for granted how nice it is to have universal hash code and universal equality, and how nice that makes our collection methods. If everyone and their brother had to, and sister and whoever, friends, had to provide an equality implementation and a hash code implementation to every collection they instantiate, would that change your opinion about this?
Well, to layer onto that though, and to play devil's advocate for you, Josh, there are things that are supported by a type indexed resolution mechanism for equality and presumably duality hash code that are simply impossible with a runtime dynamic dispatch based approach, right? Like the classic example of this is if you have some sort of polymorphic structure where like you want your sort of foo of int to have a different equality semantic than foo of string, because presumably they're not functors, they don't contain, ints or strings, they have something weird going on. This type of thing is relatively common if you do like, more advanced polymorphic structures, and you cannot solve that with dynamic dispatch. It has to be type indexed. So my converse argument to you is, yes, it's really annoying to like add a hash or eq constraint to like everything. But that pain unlocks a world for us that we didn't have before, and it solves this problem. So is that more compelling?
Well, so my closing argument is that if anything can catch the equality of option and option, like, or string versus option string equality, I think that trumps most of these different annoyances because we are strongly typed static compiled language. And that's what type system is supposed to do, I think.